So first questions first, which tools do you use on top of Snowflake?
Oh, okay. Wait, have you guys used Snowflake at all before? No?
No.
Okay. Right, so our particular stack, we have a really, really simple Python connector that is built on top of the SQL Alchemy that is already maintained for Snowflake. So it's an open source project called Snowcon that I maintain. That we use, that's very useful for, in notebooks, if you just need to read in the data, do a little bit of modeling, visualization, displayed in the notebooks. It also works pretty well for like simple use cases in for like application development. Like I said, SQL Alchemy interfaces directly with it. So anything that works with SQL Alchemy, which is like most dashboarding tools, can also interface with Snowflake. So it ends up working very, very, very well for dashboarding. Like all the major dashboarding products support it.
All right, thank you. So the next most upvoted question is actually a more, I guess, all of you can give a bit of your insight. It's how do you start in data engineering?
I guess I can start. I think three things are fundamental. You must have good computer science background. You need to understand data structures, distributed systems, this distinction between batch and streaming, and I hope you do get into a fight sometime. These are the kind of things that you learn with a computer science degree. You don't need to have a computer science degree. You can just learn it by yourself if you have an instinct for engineering. Second is you need to understand the use cases that you're trying to solve with data engineering, and that's the first step into building a data platform, is understanding the use case. So whether you're building a platform for BI or for machine learning or for something else, you need to understand their work, and it's important to actually maybe work a little bit on their side for a while. So I did the gig as a data scientist in a previous job. I'm not a good data scientist, so don't ask data science questions. But you need to understand what they do before you can build a system to help them achieve their objectives. And last thing is get your hands dirty, go and start doing stuff, because there's a lot of things that you want to learn by experience. You need to actually build the systems. You need to install an Hadoop cluster by yourself. You need to install Spark. I don't know if you agree with that, but we'll get into it later. You need to build an actual platform before you can say you are a data engineer. So I guess that's it. I don't know if you have anything.
So I think data engineering is not a whole lot different from just straight up like system and database administration. Obviously, like if you're doing any of those things, there's a bit of networking thrown in there as well. I mean, most of like the foundations I would say that I got from data engineering was just working as a full stack application developer, which I did for like, I don't know, 4 or 5 years, something like that. Which then kind of just gives you a good view of like the networking stack. It just gives you a good view of like the common tech stack that's built on top of, the internet, as well as, how things work in data centers like AWS. So also, in addition to all of that, whenever anybody asks me, how do I get started with X? It's pick a project and do it. Pick something that you care about that will need a little bit of data engineering to be done in it. And then in achieving the thing that you care about achieving, you won't really care, which particular technologies you're using, or am I studying the right thing, or this or that, blah, blah, blah. If you're achieving something at the end of the day, and you have to use some data engineering skills to do it, you're probably working on the right ones.
Yeah, it's not really that different, in my opinion, from what Sam said. I would say for data engineering in specific, as one of those more, I'm going to call it specialized fields in the industry, is that it's very important to have a use case, but more likely than not, it's very important to be almost be in a company to do it, be sponsored by someone, because if you have a use case for data engineering, then this implies that you already have some reasonable amount of data with which you want to process, right? And there might be if you want to do data engineering, at least I think as at the level that Sam and João António were referring to, you might actually need some resources, some compute clusters, even if this is just running locally on your machine or you're just setting up some AWS instances. There's naturally a money cost associated to this, and being backed by a company in some project to perform this is very, very important. Particularly for my use case, I would say that my introduction to data engineering was actually through this gentleman. And it was most of all following on a need that some people at the company at the time needed. And just having a good enough general overview of computer science and having someone in your social network almost that you can talk to and just discuss some topics is already, I think, sufficient support to start in the field. Just try to fill a need.
Yes, but like, what if like you don't have the skills to, ask money for it?
Right. Yeah. I would expect that to be a challenge. In that very particular scenario, I would say that usually data engineering, you don't do data engineering on its own, right? It's always in the context of something, as you said. There is always some need, some project that involves some notion of data processing. And if you're doing that on your own, as a hobby, as a side project, so on and so forth, well, I believe there are vouchers for cloud providers to give you some machines with which you can work. And that is reasonable for a hobby. Otherwise, you're most likely than not doing this in academia or in a company, and they have the resources for it. Trust me.
Yeah, that's a pretty good point. So like, it's not too difficult to get like $5,000 of AWS credits or something like that. It's really not that difficult for that to happen. If you look around, ask around, you can get that. And for example, the Data Science Academy has been running for like 3 years on the 5,000 of AWS credits that we got. So you can really make it last. As long as you're not standing up gigantic Spark clusters and burning through everything. You can actually build, data pipelines and whatnot that are just at a much smaller scale, but using the same fundamental technologies than something that you put into production.
And even exercising the distributed systems part, because most of it is about distributed systems and the principles of distributed systems, understanding them. Maybe you can team up with some colleagues that are competing in Kaggle and they want to distribute model training over a few machines, and you do that engineering part, and they are happy because they have someone to automate that for them. So it's a win-win.
Yeah.
So just take something and overcomplicate it?
For the sake of learning.
Yes.
And for the sake of doing it. If it's worth doing, it's worth overdoing it.
Right. Yeah.
All right. So another question, Sam. You had a huge impact on educating as an educator in the field of data science since you founded the Data Science Academy, right?
Yeah.
So what made you actually start investing in educating others?
It's the most fun zero-sum game, knowledge transfer. So when you transfer knowledge from your brain to another one, everybody actually wins. There are no losers in that game. I really do not appreciate, the very, very capitalist zero-sum games that a lot of us think need to be a big part of our day-to-day lives. I like to search for non-zero-sum games to play so that everybody involved can win, and knowledge transfer is by far the most fun of those games.
And if I may, let me just add something, that even if you feel that you don't have enough knowledge to share with others, because I mean, I guess we have our specialties, but maybe no one needs to know about them. I don't know. What I'm trying to say is, even if you feel you don't have anything to teach, maybe you can help organize what the workshops or the conferences. So just look around, see all the volunteers working in this conference, and this
we're already recruiting for the SPT Day 2020. So
no recruiting on stage, man. What are you doing? Oh my God! We all had to remove slides, man, and here you are, just like, oh my God.
I'm trying to get in the team. But yeah, look around, and it's not just by teaching, but there's plenty of other ways to contribute, and it's really important to give back. Don't just absorb. Try to give back a little, because it's really important, and it's really good. It feels really good.
Yeah, I'd like to just add one small thing there to that. In that, so what we've found at the Data Science Academy is that the people that are best at teaching something are the ones that just had to go through the pain of learning it themselves. You know, like your professor that just, you know, that hasn't learned the shit that you're trying to learn for like 40 years is typically going to be way worse at teaching it than somebody who just learned it last year and actually understands it. So it really is like, you know, as soon as you conquer something and learn it, you're pretty much already qualified to help because you went through it, you know what it's like to help other people do the same. So there's really just no reason to wait.
All right, thank you. I think that's also a really good way to teach others is to also yourself learn and interiorize kind of that whatever you learned.
Yeah.
All right, so I think the next question is going to be a bit more interesting in terms of some fighting happening here. What is, in your opinion, the most promising technology in the field of data engineering?
Deep learning on the blockchain. So, I mean, like engines that decouple compute and storage are making a huge difference in terms of like cost and performance. Snowflake is one of those, which is why I've been using it a lot. There's one that's not totally new, but it's like, you know, not quite mainstream it's not as mainstream as like MySQL or Postgres or something yet, and I think it probably should be.
Well, following up on that idea, if we're looking into the idea of, distributed systems that are useful within data engineering, that also have this notion of splitting storage and compute, I would also highly advise you guys to look, for example, at Apache Pulsar or abstraction technologies like Apache Calcite, I believe that's what it is, the SQL or what's being called the SQL for time queries, that is supported by a large number of compute engines, essentially saying that you can swap your backends however you want. That's also a level of uniformization on a UX perspective that is extremely useful for data engineering. I mean, there are so many others. Narrow this down for us, please.
I'm actually gonna name one that kind of couples computing and processing together. It's not, I don't know if it's promising anymore or whether it's a de facto technology, but I've been looking into Druid to optimize some BI use cases. It's a very cool technology that helps you that because it couples computing and storage, it helps you optimize the fact that you want to do BI, but you also want to do BI on a time series base,
right? On
a time series data. So I've been looking into it. I didn't know it like a couple of months ago, but I'm liking what I'm seeing, and I guess we will be using that in the near future.
Is that one of those like send the compute to the data rather than the other way around?
Kind of, because you have some nodes that are that will be processing real time, and there are some other nodes that will only have data that is already I'm missing the word in English, but it's already
pre-processed.
It compacted. The data is it's not the real compaction paradigm, but it's already in a format that is more that the data is stored in a more long-term perspective. So you have this kind of different nodes with different responsibilities, and you can keep you have the storage in those nodes, and the data is in those nodes, and the queries are sent to those nodes individually. Obviously, it works for operations that you can have that you can do separately, and then you can aggregate on the aggregates. You can do final aggregation on the aggregate results. But yeah.
So like, what's an example of a use case that it makes easier that would be really hard with something else?
But so, for instance, if you want to have use it for a BI use case, a star schema, you can easily use it because it aggregates the data it kind of replaces the need to have the typical data warehouse with the star schema, optimized for the fact that you want to have a time series on top of it.
Okay. Well,
and then again, I just read the paper like 2 months ago, so don't ask the hard
Still
questions.
Still too soon.
Yeah.
Well, if we're looking into that, there's also, for example, the notion of file formats at this point. I mean, in the past, a lot of people have been using, for example, simple SQL tables, or it's CSVs and that kind of thing. Well, for example, Avro or Parquet, I mean, it's starting to get a lot of support in the community, and there are a lot of technologies that now support it. But there is still way too much dependency on regular CSV files or partition files in HDFS and that kind of thing, where just simply being clever or cleverish about the way that you store data, which these file formats are, magnifies your potential with other technologies in a massive way.
We're using Parquet for columnar store, and we're trying to use Avro. But yeah, the tools available to use Avro are not very mature, so we are having some issues with that, but we're figuring it out.
But the idea works. That's the point.
It works. It works.
It works, and it works really well. And so there are some options, I guess.
All right, thank you. So this is an interesting question. How do you monetize data lakes? So that is, how can you finance the cost of having data just lying around in the cloud storage for consumption?
Have a good business. I mean, if your data is not worth any money, then it's not generating any value, then you have no way to pay for your data lake. Sorry for being
It's a money sink, essentially.
Yeah. I mean, so is that, did we mean to say monetize the data lake? Or because that just sounds like just monetizing the data itself. I don't know if the person who asked the question was here could clarify.
I don't know. I'm gonna maybe answer that in the direction. But if you want to,
I'm just looking if anyone raises their hand for whoever asked this question. I mean, it's from anonymous, so
I'm gonna answer that in the sense of trying to justify the fact that you would need to spend so much data to just have the data sitting there.
Okay. If that's what it is,
I'm gonna go into that direction. And let's say your CEO needs an answer to a business question, the next day to close some deal. It's a pretty good pretty good justification to have a data lake that is easily accessible, and this is the tricky part, but where you can go get the data, because you don't have that answer answered in your current use cases and in your whatever the story you're using to look into data daily. And you need to go back and fetch data from the past and organize it in a way that answers that question. That's a pretty good way to justify having all that data archived, possibly to never be consumed again. But then there comes the day where you need it.
Yeah, I mean, like the most important thing if it's like, okay, so if we're doing like what I was talking about earlier, of like every single time you do a transformation, you then store the data back in S3. And so for like every data point, you're storing it something like, 5 or 6 times. You're just like, multiplying by 5 or 6 times the total of your cost. Okay, that's the question, then that could make sense, right? So the whole point of doing that is to enable like disaster recovery. You need to you lose some data somewhere in the middle of your pipeline, or you have you need to compute something different, and you need to go down the entire data pipeline again, or go into some part of the data pipeline to recompute something. So the whole point of that is to save your ass in a couple of scenarios. If you can find different ways to save your ass, then that's great. Then you don't need to keep 5 copies of everything the entire time. Also, you may not need to keep everything in S3, for example, for perpetuity. Maybe you only need to keep it for like 1 week, because after 1 week, you're probably not going to need to recompute stuff or whatever, and then you can move it into like what's it called, Glacier?
Yeah,
Glacier. You can go ahead and move it into Glacier, which then just costs like 1/10 of the amount. It's really expensive to move it in and out, but you know that you're covered if you actually need to recover from some insane disaster that might kill the business.
Yeah. There's also, just to add a little bit to this, is the idea of a data lake, even to prevent these sort of disaster recoveries, which is one of the most prevalent scenarios where someone might want it, at least at first. But there are others. For example, having at certain points, when you reach a certain scale at a company or even your very particular hobby, you might have so much data that you can't find the relationships between them anymore. And this notion of data lineage has to be founded by a data lake. It's really, really hard to have data lineage and understanding the evolution of your pipelines and of your data if the data is partitioned through several services, several pieces of software, so on and so forth. Having a unified platform for this is essential for having data lineages. And data lineage might just sound like a fancy word, but if you're at the point where you need, for example, compliance, or you need to do a retesting of some experiments that you did, or you need to understand how was this model created, or things like that, how you use the data, I mean, you're going to want data lineage, and that has to be for sure backed by a data lake. I mean, there's just no way around it, at least in my mind.
Yeah, it's like business crippling things,
Yeah.
like the regulator fines you to oblivion because you can't do something, because you don't have traceability, or like you have a disaster for a couple hours in the middle of the day and then all of your customers completely lose confidence because you actually lost data.
It's like if you have a store and then you don't have trucks to take the products to the store.
Yeah, it's like that.
You don't really sell the trucks, but you need them.
Yeah.
All right, let's move to the next question, maybe. All right. Is SQL an appropriate data interface for multimedia information such as images, videos, and audio?
Yes. No. Actually selecting which file, so all of those, image, video, and audio, typically, you store those things get stored as a file somewhere, like in S3 or whatever, and then they have a whole bunch of metadata associated with them. And all of your work is usually about like, okay, how do I present which video or which image or whichever to show to the end user? Okay, displaying, multimedia is like a job for a web browser or something. It has nothing to do with a fundamental data interface. It's like your final data interface. It's like your application. So I found a way to say yes to that question.
Yeah. Nothing to add.
I guess this one is straightforward. In the end, you store the URL of the file in the database and you use SQL for that.
Yeah, because the metadata.
Yeah. Good choice.
All right, Sam, what are the things to watch out when using Lambda in between other tasks in an Airflow?
I think everybody could have something to say about that one. Right, so Lambdas, when part of a data pipeline, are usually like reacting to particular files being dropped somewhere, or like an HTTP event, or some kind of event, which means that you're not going to coordinate them using Airflow. So the thing that we had with Airflow at Daltix, which is another one of the reasons why it was a mistake for me to put the Lambdas in there and their right to get rid of them, is we had like a couple of the stages. We had like a few stages that were being coordinated by Airflow, and then some Lambda stuff happened, which then generated a couple other S3 files, which then were picked up again by jobs being coordinated by Airflow. So like the thing to watch out for is there going to be like kind of magic undocumented gaps in your pipeline that are not going to be managed by Airflow, because I don't think it really makes much sense to try and coordinate Lambdas with Airflow. I have to think about that one a little bit more, but
I don't have this experience with Airflow and Lambda in specific, but in the general sense, I guess if your Lambda functions have side effects that are documented in the return of that Lambda, because you can have a return, right? Because you can say, okay, I created this file here.
Yeah, I just mean that like if
maybe you can have,
right,
and just to finish, maybe you can have a Lambda that kind of, let's say you want to retry an operation.
Mm-hmm.
Maybe you can have a Lambda that kind of cleans up the side effects for each of your original ones, and then you can have, okay, this Lambda fails. I'm gonna start this one that will clean up whatever mess this Lambda created. If you can model your pipeline like that, I guess you are in good shape. But I'm predicting it's going to be a tough one.
Yeah, I mean, you're 100% correct on that. It's just that, if you're using Airflow to coordinate everything, typically you're using Airflow to coordinate everything. And so, you can load up one of your DAGs in Airflow, see how all of the data is flowing through all of your systems, except for this one part, which is going to be managed in some other thing somewhere else that's just not represented in Airflow. So, like, you onboard somebody, you're like, hey, here's our data pipeline, except for this part over here. That's just like, when you're the one that designed the system, that's always embarrassing. You have to say that.
Yeah. I have nothing to add to this. I don't have any experience in Airflow, actually. So.
All right. Sam, you also said that it's a hassle to manage Spark cluster for your use case. What were the biggest issues you had?
Hiring. Yeah, no. So like what happened was like a really, really good data engineering firm out of Belgium that has a whole lot of Spark experience built a part of this of the pipeline for us. Even those guys who are like experts and been working with this for like 10 years, for like the first week or so after they deployed it, every once in a while would like have to go in, interpret these big gigantic stack traces, tweak something about the cluster, the partitioning or whatever, and then redeploy it. And then those guys ran out of availability, so we had to start taking care of it ourselves. So then we spent about a year trying to hire somebody on a startup budget, which didn't really work out that well, which meant that Mr. CTO was losing all of his weekends to learning how to admin a Spark cluster. And a lot of what those things were doing were jobs that we could do in Snowflake with a couple of SQL commands that just never really failed and scaled up and down as much as we wanted to.
I thought you were gonna say JVM, but I guess it's kind of related. I mean, if you want to have a Spark cluster, please make sure that you're actually doing some heavy loading, because if you're not doing heavy loading, you probably don't need a Spark cluster. If the data fits your computer, you don't need Spark.
So what percentage of the time did you see Spark clusters in production where they didn't need it?
Moving on.
Let's not
no, yeah, it's true. And if you want, and if you really need to have a Spark cluster, you do need to have people specialized first in the JVM Java ecosystem, because when you start doing heavy lifting, you need to start optimizing things, and it can be a mess. And then you, of course, specialize on the Spark framework, because there's a whole lot of things to master to actually have a Spark cluster running in a productive way.
Yeah. Just to add to this, if you have a Spark cluster for a very well understood data set or data topic almost that you want to handle, you do your configuration and you're probably okay. The issue usually becomes when you have extremely dynamic workloads, where at some points you might have massive partitions compared to others, and you clearly need to scale your cluster in some fashion. Or in other scenarios, you might have I don't know, things like taking way too long because you have so many machines in your cluster, and you're splitting by so many little files that you're losing time. And these sorts of clusters, especially if they're in the cloud, this is going to cost you a lot of money. So there's a lot of config. It's very fine tuning. It's a Formula One car, and a lot of people don't need a Formula One car.
And it's a full-time job doing that fine tuning if the cluster is big.
Yeah, exactly.
All right. I think that's pretty much almost all the time we had. I just maybe have one last question for you guys, a bit more general. So what are you currently learning as a data engineer? Because you should be always updated, right? I guess there's always new technologies. So what is the thing that you're learning, reading about lately, or just share something that you think would be interesting also for the audience to check out?
I can start. I already talked about Druid. I'm also trying to understand how I can have Druid using SQL, because it's an important part of the platform to be kind of self-service. So there are some ways to have an SQL interface with Druid. So I've been looking into that, and surprise, I didn't know. I had no experience with Kafka yet. So I'm learning Kafka now. So it's one of the cornerstones of any decent data platform nowadays. Yeah, that's it.
Go ahead.
All right. Well, I think essentially was the essence of my talk, but stream processing in general, at least what we have as state of the art and what use cases it matches. This in particular for data engineering. On a side note of that, something that, at least in my mind, may become useful in the future is the notion that Sam talked about protocols. It's something that I'm very, very interested in. And I believe that's in the future, for a lot of sources and a lot of software, if the interaction is through things like HTTP, then cross-language solutions like, for example, automatic Swagger documentation or cross-compilation of languages to give you type-safe languages with which, or SDKs with which to interact with these pieces of software will be quite interesting and will have a significant impact because it will allow you in multiple languages to use data engineering technologies.
And if you want to do multi-language, serialization systems are also a thing you need to look into it. And so, for instance, I've been using Avro, but there are others, Protobuf.
Cap and Proto.
I never remember the other one that is very popular too. But
Arrow.
Yeah, so you have to look into serialization system to be able to communicate between multi-language platform.
Yeah.
So like data lineage and artifact management, like, you know, it's always been a huge part of every project that I've done. I've never really found a tool that I really liked. Most recently, tried using MLflow, and it was all right. Did the job. Was not amazingly happy with it. And then also, you know, making as much of the infrastructure, making as much of like the data infrastructure as code. So like, you know, all of your S3 buckets, configurations and whatnot, and your, you know, whatever RDS is, blah, 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 all need to be managed by, you know, Terraform. You know, the, you know, data artifacts themselves, probably with, you know, DVC, although that's not quite infrastructure as code. You know, using serverless, for example, or, you know, to deploy your Lambdas in a declarative way. It's just like, you know, a lot of these data, also like in Snowflake, the schema, the databases, the schemas, the tables, and then all of the permissioning around it, which is hugely important for privacy. You know, those are starting to have some terraforms and some more ORMs. So basically, like everything declarative infrastructure as code. I'm never happy with how that works.
And one last one, because you're talking about infrastructure as code, guys, learn Docker and Kubernetes because you're gonna need it.
Yeah. Just do it. YAML's not fun, but just do it. Also, data lineage, Apache Atlas. Have you looked into it?
Just a little bit, not much.
All right.
I will.
If you do, let me know.
All right. Guys, thank you so much for this session. I hope that you guys also learned something from out of it. Maybe let's have a big round of applause for our speakers. Thank you.